Welcome back after absence of few weeks now. Back with a new video that is basics of OSPF. So we're going to take a look at today how best to enable OSPF, some of the basics of OSPF, how we can use various different commands, and some of the basic requirements and verifications. So in this topology we have R10 and R20. They are directly connected using a prefix 10.14.0/24. On the R10 side it is 10.14.10 and R20 it is .20. We're going to enable OSPF between R10 and R20 on the point-to-point interface in the area 0. So we have various options when it comes to enabling OSPF. So first of all, we have the let's take a look on the options available we have for the OSPF. So we're going to say that in this topology we're going to use area 0. So between R10 and R20, it's very straightforward interface, directly connected interfaces. We're going to take a look at some of the basic requirements and later on jump onto the CLI and configure. So the options available to us are, so first of all we can go under the interface and enable OSPF for per interfaces basis using IP OSPF area command. And the second option we can use in iOS is we going to enable under the routing process using network statement. So these are the two more common ways of enabling OSPF in the iOS, although in the later videos we're going to take a look at iOS XR and various different ways of enabling OSPF in the XR. So for the purpose of this video we're going to go ahead and take a look at the CLI on the R10 and R20, and first of all going to configure and then look at some of the verifications for the basic OSPF config. So let's jump onto the CLI and take a look. First of all, we're going to configure routing process on R10 and we're going to set the router ID. Router ID in this case is the loopback 0 IP address of R10. When configuring OSPF we have two choices really. Running OSPF directly under the interface, that is done by entering IP OSPF and process number and area command in the interface configuration mode. The second option is achieved by using network statement along with area and inverse mask under the routing process of OSPF. So for R10 we've used a command under the interface and we set the IP OSPF 1 and area 0. So we're going to move the Ethernet 02 under the OSPF process. We're going to take a look at the config by using QIP OSPF interface brief command. We know that the ETH02 has a process ID of 1, area 0, and the prefix on the interface is 10.14.10/24, and we have a cost and a BDR is the state of the R10. Next, on the other side of the link we have R20. And what we're going to do is we're going to log on to R20 next, and in there we're going to first of all configure obviously the routing process. So the R20 is the other end of the link that's connected via the ETH00 towards R10, and we're going to log into R20 and first of all configure the routing process. So similarly to R10, we configure a router OSPF process ID of 1, set the router ID, that is the loopback IP address of R20. That's the loopback IP address set on in this topology for R20. So we're going to set that as a router ID. After the router ID, in this case we're going to use the network statement under the routing process. So first of all check the config of interface and and the OSPF process so that we can add the prefix under the routing process for the ETH00. So interface ETH00 has 10.1.4.20 on the R20 side, and what we're going to do is we're going to go under the OSPF process, and that is process number 1 in this case, and using network statement we're going to add the directly connected interface to enable OSPF. We're going to set the inverse mask and set the area to 0. We see that the adjacency has come up as the OSPF is enabled correctly on both sides. We're going to just take a look at the show IP OSPF interface brief, and we see that this side is also showing state as BDR. What we're going to have to do is clear the process, and then the R10 is going to be the DR for this segment. Next, we're going to take a look at the IP OSPF database on R10, and we see that in the database we have the prefixes both from R10 and 20. However, see a prefix from R30 as well. That is another neighbor for one of our next video. To check the things like MTU bandwidth and the reference bandwidths, we can look at the interface command including BW. That will give us a delay, bandwidth, and etc. information. We're gonna take a look at in a separate video about how the OSPF reference bandwidth works in this series. And next we're going to jump on to R10 and take a look at OSPF route, and the command show OSPF IP OSPF route is going to give you all the prefixes directly connected, intra area, and received prefixes. So you see that the greater than sign is not used for the prefixes that are directly connected. So thank you for watching. If you like the video, please subscribe, and I look forward to see you in the next video of this series. Thank you. Bye.